So, hello everybody, welcome back. We are on video 2 for chapter 11 on agriculture. And we finished off in chapter 1 with pesticides. So if there's something you don't know, understand about pesticides, please make sure you ask questions in class. We will go over pesticides a little bit, but pesticides are very important. So I want to make sure that you don't have any questions. Okay, so today in this video, we are starting off with genetic engineering. GMOs, genetically modified organisms. Okay. There are pros and cons to genetically modified organisms, to GMOs. And honestly, it depends on where you stand. Not all of the GMOs are bad. They really aren't. There's a lot of good benefits to them. So one of the greatest benefits is that they have a really high yield. We are literally increasing the amount of food produced per acre. So if you were producing corn without a GMO, you might get 8 bushels or 80 bushels a acre, and with GMOs, you get 120 bushels per acre. So we're really increasing our yield. There's usually a lot of times greater food quality. They're made so that pests don't bother them, that they come out very nice every time. They're resistant to disease. They could be larger. They could stay fresher longer. That kind of thing as well. So you can improve the quality of the food. Reduction in pesticides. One of the we can breed them or engineer them so that they are resistant to pests, resistant to disease, which is going to make it so you have to use less pesticides, theoretically. Reduction of world hunger by increased food production. If we can grow more food per acre, we can grow more food and therefore potentially feed more people. And increased profits. If you are producing, it takes the same amount of energy to grow an acre of corn, whether you get 80 bushels off of it or 120 bushels off of it. So if you're paying the same price to plant it, water it, feed it, whatever, take care of it, and you are getting 40 more bushels or increasing your production by 50%, that's more money in the farmer's pocket. That's more profit. So that's also a positive of genetic engineering. Okay. Concerns about genetic engineering, GMOs. There's a lot of concern about human consumption. What is it going to do to us to consume these genetically modified organisms? A lot of the GMOs that we currently have are probably completely safe for human consumption because they're genetically modified where we've combined different aspects of different tomatoes to make a certain tomato. We could have done that through breeding, just like we have with dogs and horses and chickens, and we have different breeds of them because of breeding and just taking our time. Or we can go and do it the quick and expensive way, if you will, and genetically modify them. So a lot of your genetically modified vegetables and stuff in the grocery store are probably completely safe for consumption. There is a concern when you get to things where we're taking genes from other organisms and splicing them into our food that we start to get concerned. And I can understand that kind of concern. Right now, almost all corn and soy are genetically modified. They are genetically modified with a gene from a bacteria that is resistant to Roundup. If you splice this little gene from this bacteria into a plant, into a cell, that cell is now resistant to Roundup, which is an herbicide. It's sprayed on fields to kill the weeds. So if I plant what's called Roundup Ready corn in my field, then I can go spray that field with Roundup anytime I want. It will not kill my corn, but it will kill any of the weeds that are competing for the nutrients in my soil. If I have a lot of weeds growing in my field, they're pulling out the nutrients that I want to go to my corn, and that's not good for my corn production. Okay, so I can understand that kind of, when we start crossing animals, we're not so sure what that could do to for us when we consume it? Probably nothing. It's probably safe, but we're in a big push right now that we need to know what our food is, and we need to be made aware if we are eating GMOs. And I have no problem with that, but I don't think most people fully understand what a GMO is. GMOs decrease biodiversity. A lot of times we end up with monocropping, and when you have a GMO, every single organism in that field is genetically identical, completely 100% identical, because it's been manufactured that way. So there is no genetic diversity within your species, and there's no genetic diversity in your field, and that is going to increase biodiversity in the area and stuff. It's going to eliminate some organisms that would feed on other stuff, and it's going to increase, the population of the one pest that can eat your GMO kind of thing. So that's a problem. Regulation of genetically modified organisms. Here's the biggest problem, in my opinion, with GMOs, and that's that our government has allowed for the patenting of genetically modified organisms. So if I alter the DNA of something, I can patent it. I can have it, and that means I own it. It is mine. You can't have it without paying me. The only problem is living things like corn reproduce on the wind. They blow their pollen around. So all that pollen that gets blown off the GMO crop belongs to me. But I can't control it. So it goes and accidentally fertilizes the farmer next door's crop. And now their crop is genetically modified, whether they wanted it to be or not. And now I can sue them for it. And that is a huge issue. I mean, they didn't want a GMO crop. Honestly, they should turn around and sue for trespassing, because my pollen ended up in their field without their permission. And they are literally shutting down farm after farm after farm, because if you don't plant and grow the GMO, they will come after you. They will, basically sue you. And these are companies like Monsanto, who has huge billions of dollars and huge control and lots of lawyers. And it's kind of sickening. That's the part of GMOs that really upsets me the most. And Monsanto and these other companies that patent the GMOs, they control that production from the entire way. They sell you the GMO seed, you grow it, you buy the Roundup or whatever, from them that you're going to spray on the field, and then you then basically have to sell it back to them, or you are selling it back to them because they're the biggest buyers. They buy it back. You can't do any seed saving anymore. It used to be that you save some of your seed one year to plant the crop the next year, and you can't do that anymore. You have to sell every single seed to them, every single bit of corn or soy or whatever, and then you have to turn around and buy new seed the next year from them. You just sold them your seed that you grew, and they're paying you a couple bucks a bushel. And then you have to turn around and buy it back, and you're buying it for 20 times that a bushel. So you're paying 40 bucks a bushel to get the seed back that you just sold them. It's just bad all around on that end. But unfortunately, there's not much we can do about it unless somebody wants to be an environmental lawyer and sue the crap out of them, which I would love. I will totally work for you and help you do that. Okay. Moving on, if you have questions about GMOs, ask me in class. We can go over and discuss it further. But remember, there's pros and cons to everything, because honestly, GMOs, if you're planting them, you don't have to have as much farmland. So guess what? I can leave that forest over there, and I don't have to cut it down and make more farmland to produce the food. So it is a double-edged sword. I just wish our country did not allow the patenting of life. That's a slippery slope that we've gotten into, that who knows what's going to happen with that. Okay, farming methods. Right now, conventional agriculture is basically industrial farming. You use tractors, you use machinery, you use potentially a GMO, you plant in rows, it's, you know, it's monocropping. There's field after field. You go out, you plant your seed, you take care of it. You might use some irrigation stuff, and, you know, you harvest your crop. Traditional farming is prior to our marine, the type of farming that occurred prior to our industrialization, prior to the use of tractors. Very much hands-on. A lot of our organic now is a little bit more traditional. It's a little bit more human labor use. We use us to plant the seeds and harvest rather than machinery. Shifting agriculture. Shifting agriculture is basically also could be known as like slash and burn and stuff. You plant an area for a few years. When the soil is depleted of all the nutrients and stuff, you're going to just move to another area and repeat the process. The idea with shifting agriculture is maybe that you have 1,000 acres, and like every year you use 250 acres. So you use 250 for a while, the other 750 sits empty and is kind of being renourished and stuff. And then you just rotate through your land on a basis. Every couple of years you shift to the next segment. By the time you get around to the one you used a few, 12 years ago, it's pretty nutrient rich. So, but again, not all your land is being used, or it can be more of a slash and burn situation where I'm just cutting everything down, burning it, using that, and then I move on and totally abandon that. And so I'm destroying lots of forest and lots of nature as I'm shifting my agriculture because of the nutrient content. Nomadic grazing. We see this a lot in way back when, in nomadic herds or groups. In Africa, there's still some nomads. Maasai are a nomad. They basically move their animals, and as they kind of go, they migrate, if you will, and they move their animals, and they move them prior to them completely destroying an area. So they move them into an area, let them graze it for a while, and then they move on to graze another area, and they just keep moving. They have somewhat of a pattern of their movements, but they keep doing that rather than just the animals sitting on a pad or one area for a long time. One of the consequences of our current agricultural process is desertification. And desertification is when we basically are turning agricultural areas into desert. Basically because if you remove plants, you remove transpiration for the water cycle, and you actually reduce the amount of water or rain that is occurring. So the more agriculture you have, actually the less rain you have. Because those plants that you plant in there for a few months of the year are not releasing as much water as a forest would. So you're actually decreasing your thing. You're also depleting the soil, so nothing can grow there. If nothing can grow there after you're done growing, then nothing grows, and now there's absolutely no transpiration and there's no water going on. And we're basically turning areas into desert. What's happening really is areas along kind of the edge of deserts where our prairies are, we are now we have been using those areas for agriculture, and they're getting really bad because they were pretty low in rain anyways, and now they're really low in rain, and now they're turning to desert. So what you would see if you look at this map, this is all desert anyways. So we're expanding our deserts. Most of this is desert. We're expanding it. Most of this is desert. We're expanding it. So what's happening is a lot of our deserty areas are expanding because we're losing that area. And I better cut this off. But desertification is a big, serious consequence of our current agricultural practices, which is kind of scary. The last thing we need is more desert. Okay, see you in video 3. Bye.